Hi, everybody. My name is Kirk, and I'm going to be talking to you today about property-based testing. I am super nervous, and when I do that, I make bad jokes and I talk really fast. So let's just see how this goes. Cool. So what is property-based testing? What are we covering today? Framing is important. So we're going to look at how we normally test or usually test and what can go wrong there. We're going to get into what is property-based testing and how can it help. Then we're going to look at some examples of property-based testing because examples are good for like solidifying information. And then profit, I assume. I don't know. We'll find out. Okay, so let's just like take a step back to get some context. Context is always important. So program testing in general. I found this definition. I really like it. It feels very sort of like official and right. The checking by means of actual execution, that's super important, whether a program behaves in the desired manner. The program is executed and supplied of test data, and the way in which the program responds to this test data is analyzed from a dictionary of computer. So that's testing in general, right? And that's what separates testing from like going, oh, I think it works, right? Like you have to actually try to run it, which is super important. And then we get into sort of automation testing or automated testing versus manual testing. Automated testing, software technique that performs basically using software tools to test software. Manual testing is where we just try and figure it out. And all developers, as far as I know, do some sort of manual testing. We're always doing manual tests, just like the code work, check it out. Hey, you check it out, and that's great. But it's very difficult for that to scale, and that is why we came up with automated testing. So we're now going to see like, okay, what's the normal kind of automated testing? And I'm doing this from the context of the full term. So I know for the people who are sort of like test experts, just chill out. You know, we're going to get into some cool stuff soon. And for the people who are new to testing, maybe this is sort of a gentle introduction. Okay, so generally with automated testing, a developer writes some assertion that a computer program can check. A test runner, which is just a fancy name for software designed to run tests, executes that assertion. The test runner reports back to the user whether their assertion passed or failed. And that's it, right? It's just code that will go check if what you said will happen, like will happen. And let's see if we have an example. So here's an example, just like a general idea of like the simplest possible test. So most of this talk is in TypeScript. So if you're familiar with JavaScript, it should look okay. If you're familiar with TypeScript, obviously it should look okay. And it just felt like sort of like the natural midpoint language for most folks here. So here we're saying, okay, from some my cool calculator module, we have a calculator object. And we're writing this very simple test. I think this syntax is using the Mocha testing framework. And we're saying, like, okay, it should add two numbers correctly, because apparently that's like a thing the calculator should do. So we give our test a name, and then we pass the function that's going to actually run the test. And here we say, okay, let's make two numbers, and let's add those two numbers using the API that we want to check out. And we expect this result of adding the two numbers to be 7. It's 3 and 4. It should be 7 if the universe still works the way that it worked yesterday. But who knows? It's 2021. Cool. Now I'm going to attempt in a really scary way to show a different screen and jump to my live app. That was not as smooth as I wanted. Forgive me. Because like small examples are fine, but sort of like more practical examples I think are really good for people, just to sort of get like a cool overview of like a real application. So I made this Roman numerals converter in React. Do not judge me on my design skills. This is not a design talk. I will cry. And yeah, it's just a Roman numeral converter because I like Roman numerals. So hopefully if you do this and you hit convert, it does that. And then here you can work with the opposite. That's a good Roman numeral. MCC. It does that. Not every number becomes a Roman numeral. So if I try to do this with like, it's over 9,000, hey, that's not right, right? And the same thing here, if I try to do this with like something that isn't like a Roman numeral, whoops, Butts is not a Roman numeral. So like, this is the application that we have, and this is the API we're trying to test, and we're trying to make sure that this does what we want it to do, and we're going to use unit tests to help us with that. So let's kind of like jump back into that. If I can find where I kept my slides. Why did I switch screens? Okay. Okay, and this is just another sort of screenshot of what we were looking at there. So let's talk about the app for a little bit. So, oops, I'm out. There we go. So our app has a module called Roman numerals that exposes a single class Roman numeral. The only way to make a valid Roman numeral is through two methods, either from int, where you pass it an integer, or from string, where you pass it like a string that's supposed to be a Roman numeral. And these methods return a result. If the conversion was successful, we get back an okay, hey, the thing you passed me can totally be a Roman numeral. And if it was unsuccessful, we get back an error, because that can't happen. That's not real. So how does that API work? I wanted to just like show a quick practical example. So here is sort of the code. So import Roman numeral from Roman numerals, getting our object from our module. And here it's like, okay, we can do Roman numeral dot from int, we can pass in 5. We can check if it's okay, and it tells us that's true. If we look at the type of the result, it's okay Roman numeral, and we can get the value from it. But if we passed bad value, then we wouldn't get back an okay, we'd get back an error. And an error is basically a data type that just has like a name and a message of what you did wrong. Cool. How do we test this? So here we're going to do like the standard unit testing thing. We describe a set of unit tests, standard unit testing, our Roman numeral API, and we have a series of tests to see if our program is working. So the first one is, hey, it should convert like 5 to V. So here we pass in 5 to our Roman numeral from int 5, and then we expect the value as string to be V. We can do it with bigger numbers, should convert 1,234 to, I'm not going to read all that out, that's a very long string. We can also test that it invalidates certain things, right? So it should reject numbers bigger than like 3,999, because that's the limit that you can make of Roman numerals. So here we're making it with 8,000, and we're saying, hey, the result should be an error. It should not accept that value. And this is super cool, right? But there's a couple flaws with this testing strategy, and we are going to sort of dive into them. One, we can only test one input at a time. There are essentially 4,000 Roman numerals in this implementation, but like I'm not going to write 4,000 tests. So, we'll do like some of them and hope they're okay. The values we're picking for this test are arbitrary, right? Like I chose 5 and 1,234. There's nothing particularly special about them. If there was a problem, say, with like representing 7, I wouldn't know because there's no 7 in the things that I picked. If there was a problem with like 90, I wouldn't know because like I haven't picked those. And we are hard coding these values into our test, and we could maybe put them in a file or put them in some sort of like tests loader. But at the end of the day, we're still saying like, hey, do 5, do 90, do 25. And if our domain changes for our application, we have to switch out all these tests, which is kind of annoying. And the main thing, all of the above problems are multiplied by the amount of things that we need to test. So every time we have a new part of our application we want to validate, we want to get like a nice cross section of the available values. So we're sort of doing these things over and over. The rules of Roman numerals you'd think would be simple, but they're kind of not. Roman numerals have to be in this range, and they can only be these letters, but only this amount of these letters. and they have like special cases for these numbers where they change to something else. They have two representations, and then these have special cases too. So you have to sort of backtrack to make sure that all works out. And they're uppercase only, you know? So that's kind of messy. So like, is there a way to avoid these problems in testing our application? Well, I hope so, because otherwise I would be doing this talk for no reason, and that would be really stressful. So there is property-based tests, or fuzz testing. So this is a two-part definition. I like it because it is clear and concise. We will also look at sort of a simpler definition that's like a little more straightforward. So property-based testing is the construction of tests such that when the tests are fuzzed, failures in the test reveal problems with the system. And fuzzing is just feeding in code from a large set, usually in a random way. So another way to think about this, property-based testing checks for how true things are. So you would have a statement like, hey, for all some range of values, there's some precondition like this, there's some property we want to check, and let's see if that's true. This is a direct quote from FastCheck, which just happens to be the JavaScript testing library that we're going to use to show property-based testing. So let's jump into that. The key factors of property-based tests are you, the developer, do not choose the individual values that are being passed into your system. So the way before we were like, hey, check to see if 5 is V, check to see, we do not do that. You define the domain of values you want to test, and then you write a test that compares a property that should be enforced by everything in that domain. The test runner will generate arbitrary values, essentially random values within that domain, and ensure they possess that property. And let's jump into an example. So the first thing you do is you import FastCheck, your regular npm install, yada, yada. It exposes one thing, which is FC, where all our functions and attributes come from. And here is the interesting part. So we have a test. Should accept values between 1 and 3,999 inclusive. How do we do that? Well, FastCheck exposes these things called arbitraries, and there are different arbitraries for different data types. So what we can say is, let's do a set of integers between 1 and 399. And this line here will essentially produce about 100 random values in that range for us. We don't have to pick them. The test runner will just choose 100 random values in that range. And then our actual test to see if they're true is super straightforward. It's just any other function. Hey, if you give me an int, I will make a Roman numeral for it, or try and see if it's okay. The final thing we need to do is here where we say fc fastcheck assert test this property. If you put in these arbitrary valid integers, this test should be true. And it's going to go off to the races with that. So what it's going to do is it's going to make about 100 random inputs. You can adjust that, but typically it defaults to 100. They're pseudo-random, so it will check extremes. So if we're doing just integers, it would check super big ones, super small ones, negative ones, like kind of hit those pain points. It will provide a seed for each run. So once you have the seed, you can rerun that exact run later if you want to see the exact values again. And it shrinks results. So if it finds an error, the test runner will know I should concentrate my tests near to that value to see if I can figure out exactly where things break. And I have an example of that here. So property failed after one test. The key things here, here's the seed of the test run. If you want to do this exact run again, it says, hey, here's the counter example to what you said. Here's what goes off. It tells you how many times it shrunk. And look, it started with a random value of 5,161, and it went all the way down until it hit 4,000, because at 4,000, that is where our API goes from OK to error. So that's pretty cool. I want to quickly show you some cool things you can do with manipulating these. So testing when things are okay is great, but you also want to test when things are not okay and when you don't get the values you want. So should not accept values less than 1 and greater than 3,999. Well, how do we set that up? Here, we can just tell, hey, give me arbitrary integers, and then let's just filter them by the properties that we need. And now we get a generator that would produce arbitrary integers, but not in that bound. You can essentially treat these arbitrary values the same way you would treat like any sort of like array or list, and you have similar properties on them. So it's super easy to make these things. And then our test just like, yeah, these should be error instances, and we're good to go. A more fancy one, transforming values. What if we wanted to see if they would put in an int and get valid strings back out, right? So now we're actually testing the values coming out of our API. Well, first we need to do some dark magic, and this is the regex that actually sees if a string is a valid Roman numeral. This is not the talk for saying why this regex works, but just trust me that it does. But now we get to do something really cool. If we want strings to test, well, we can do our valid inputs, map them to Roman numerals, and then map those values as strings, right? We can essentially just like do a chain of operations to transform our random ints into random strings for testing. And then we're right back to here. Expect these values to match the regex. And that's super cool. So you can very easily transform basic values into more complex random values, and that's super powerful. So yeah, you should try out property-based testing on your next project. It's a great way to test that your APIs are valid. It falls under the principle of code as documentation because there's no magic numbers, right? You're defining like, this is the domain of inputs, this is the domain of outputs, and making sure that like those correspond. Defining domains is a great way to help with app development. Also, if your domain changes, you just modify the arbitrary like definition, and you don't have to worry about updating stuff later. Easy to modify if the application changes, and it's a super great way to mock objects, API calls, JSON data. If you're trying to test user data, like you can, like if you know the shape of what your data should be, you can make arbitrary values for it, and it will just make them for you. And it's a great way to like really discover if your application is handling inputs the way it says it should. If you want more info, there is the GitHub link for a fast check. They have great documentation. It's like very fully featured. Absolutely check them out. There's a ton of built-in fuzzers. So they already have stuff for web URLs, for email addresses, lorem ipsum, complicated strings, simple strings, objects, functions, anything. I haven't used that one yet. That sounds super dangerous. Really cool stuff. Or if you want, you can also like ask me. I can do that too. Yeah. That's kind of it for the slides. The last thing I want to do is to just maybe show you if, let's see, if I can quickly show you some actual code. I'm not going to run anything. I'm not as cool as Vic and the others. But like this is the actual code, and like most of the examples are pulled from like my actual app. So it's just like a simple React app. And let me just hide these meeting controls. So this is our Roman numerals module that we're testing. This is like all the functions in here, and like proper unit testing. Like we're not checking what's happening in the module. We're just making sure that its API works. So here we have our tests. Here are standard tests, just our regular unit tests. And this doesn't have to be either or, right? You can mix in regular unit tests and property-based tests. It's fine, you know, like do what you need to do. Here's our property-based tests, which you've seen, you just saw like most of these. This is a super cool one where I made arbitrary Roman numerals, just building up from the basic types. So that was super powerful. And yeah, all strings should be accepted. Invalid strings should be rejected. We're just comparing them to the regex and like rejecting the ones that fail the regex. So you can use maps and filters to kind of make anything you want. And yeah, my final test is if I take a string, make it a Roman numeral, get an int from that, make that a Roman numeral, get a string from that, then I should get back the string I started with. And that's like really easy to set up with this. And there's no magic values. It's just all types I want in, types I want out. Yeah, I think that's it for me. Thank you for listening to me breathlessly talk through this.